Bismillahirrahmanirrahim. Today I am going to make a video and solve the paper of Cambridge Igcse, and the subject is Physics P4. It's a theory extended version. Subject code is 0625 and the variant we have is 42. For the session of May-June 2023, we have 1 hour 15 minutes for this paper, and this paper carry 80 marks. And the important information in the instruction is also given that we have to use the value of G, that is equal to 9.8 gram meter per second square. So we start our paper from the question number 1. Question number 1 is that figure 1.1 shows a helicopter which is stationary at a height above 1500 meter above the ground. We can see helicopter is flying in the air, that is exactly 1500 meter above the ground. State the two conditions necessary for the helicopter to remain in the equilibrium. What is equilibrium? When all the forces acting on the body and the resultant force is equal to 0, it means that body is in the equilibrium, or all the turning effects or all the movements that are sum must be equal to 0. You can say that sum of clockwise and sum of anti-clockwise movement must be equal to 0, or resultant movement must be 0. So we are gonna write these two conditions over here. So resultant force must be resultant force must be 0. That's the condition number 1 for any object to be in equilibrium. And the resultant moment or the turning effect of the body must be 0. So we're gonna write over here resultant moment must be 0. Moving to the next part of the question, the mass of the helicopter is 3200 gram. Calculate the change in the gravitational potential energy of the helicopter as it rises from the ground to 1500 meter. So this is the value of m, this is the value of h. We're gonna use the formula for the potential gravitational potential energy. We have the formula, that is potential energy is equal to mgh. M is the value that we're gonna use 3200, and g is given in the instruction, that would be 9.8, and height 1500, which is also given. After multiplying it, we're gonna get 4.7 into 10 raised to power 7 joule, or you can write 47 megajoule. In any form you can write your answer, both would be considered correct. So we are writing the standard form 4.7 into 10 raised to power 7 joules, or you can write 47 megajoule. Moving to next part B, figure 1.2 shows a vertical speed time graph for a parachutist who jumped from a stationary hot air balloon. We can see that when the parachutist jumps, for its initial speed is 0, and the object start from point A, its speed increases, so the object is accelerating at this point. Okay, the parachuting, other information is also given. The parachutist jumps from the balloon at time t is equal to 0 and reaches at the ground at B. The point A indicates when the parachute opens. So parachute is open its parachute at point A. Okay, on figure 1.2, label a point on the graph where the acceleration is 0 with 1. So we have to figure out when the acceleration is 0 when the speed is constant. So this is here, we know that speed is not changing, so acceleration will be 0 here, and here also the speed is not changing, acceleration is the change in velocity, the velocity is not changing at this point as well, so acceleration will be 0. So we're gonna moving to the next part, negative with 2, and the acceleration is negative, we have to write 2. So we know that From here the object is acceleration is 0 and its acceleration start to decelerate, and we know that over here the speed is increasing, so object is accelerating. But at this point we can say that its slope is not increasing in that way. So we're gonna write over here, when the object is negative acceleration, its acceleration is decreasing over here because speed is decreasing. So we're gonna write over 2 over here. Why we're writing 2 over here? Because it start to decelerate, and when it start to decrease, this is the point where it starts to decrease. So there's a difference between deceleration and decreasing. Moving to its next part, explain in terms of forces the changes in the motion which occur from when the parachutist leaves the hot air balloon under point A. Okay, when the parachutist leaves the parachute at point A, it starts, because initially at t is equal to 0, when the weight of the parachutist is greater than the air resistance, so it will start accelerating. But at certain time its air resistance become increasing and almost become equal to the weight. When when the air resistance and the speed of parachutist increases, the air resistance acceleration now slow down. Here we saw that acceleration and reaches a point where the weight becomes equal to the parachutist. So when the weight becomes equal to the parachutist, it means we have reached at the terminal velocity. This is the terminal velocity we are showing over here. When parachutist jumps at point T is equal to 0, initially the weight of the parachutist is greater than the air resistance, so it will accelerate because its weight is greater than air resistance. As the speed of parachutist increases, the air resistance acceleration now slow down, and it reaches a point where the weight becomes equal to the air resistance, and this point is known as terminal velocity. At terminal velocity, acceleration is 0. We have figured it out by labeling it to the one in the diagram. So hopefully you would get that answer. Moving to its other part, moving to the next question, question number 2. Okay, hopefully you can see now. Okay, question number 2 is from the topic of energy. A student catches a cricket ball. The speed of the ball immediately before it caught is 18 meter per second, and the mass of the cricket ball is 160 gram. Calculate the kinetic energy in the cricket ball immediately before it caught. The formula for the kinetic energy we're gonna use is 1/2 mv square. We are provided with mass as well as velocity. 1/2, and the mass is 160 gram. We're gonna divide it by 1000. The mass would be 0.16 kg. So we're gonna write over here 0.16, and the speed is also given. Speed we're gonna take is 18 half mv square. The formula is we're gonna write over here 18 square. After calculating it, the answer will be 25.9 joules. So we're gonna write over here 26 joule into significant figure. We are writing over answer. So this is how we have calculated the kinetic energy and give our answer in the form of 2 significant figures. Now moving to the next question. Next part, it takes 0.12 second to catch the ball and bring it to the rest. Calculate the average force exerted on the ball. We know that the formula for the force is F is equal to ma, and the mass we have converted into the kilogram. We have used previous case 0.16, and we have been given with the time is 0.2 second. But acceleration, we don't know what is the acceleration, but we know the formula of acceleration. Acceleration is change in velocity over change in time. I'm gonna use v minus u by t. What is v? We know that it is 18. Now it comes to the rest. The final speed would be 0, and we're gonna divide it by time. Time is 0.12. 18 divided by 0.12, 0.12, we're gonna get our answer. That would be 150 meter per second square. Meter per second square is the unit of acceleration. So we're gonna multiply 0.1516 by 150. So our answer would be 24 Newton. So we're gonna write over here our answer 24 Newton. Moving to its C part, as a student catches the ball, she moves her hand backwards. Explain the effect of the action on the student's hand. Okay, when she receives the catch, it's actually it pushes its hand. So we have to explain this effect. The action creates longer time and therefore it reduces the force on the student's hand. So we're gonna write that this action creates longer time, therefore reduces the force on the student hand. So we're gonna write over here the action creates longer time and therefore reduces the force on the student hand. Reduces the force on the student's hand. Moving to the next question, question number 3. Question number 3 is from the topic of pressure. The figure 3.1, now you can see figure 3.1 shows a person moving across an ice covered pond to reach a ball on the ice. Why it is like that? Because the person doesn't want ice to break, so it is increasing its surface area by increasing more contact area with the ice. When the surface area increases, pressure actually decreases. This is the formula for the pressure, force over area. When the surface area increases, obviously the pressure gonna decrease, so the pressure on the ice will decrease, so it will not break, so the person can safely catch the ball by this position. So we're gonna explain why the moving across the ice is safer while walking. So we do not use to walk, because if we touch the ball by walking, our surface area decreases and the pressure more will be applied on the ice, and ice have more chances to break. So we're gonna write that the weight of the person is spread over a much greater surface area will become P is equal to F over A. Force remains the same, so when area increases, pressure decreases. So ice is unlikely to break. Now we will move to the other part of this question, part B. Okay, you can see that figure 3.2 shows a side of a view of the pond with a layer of ice floating freely on the water. The surface area of the pond is 5 meters square. The mass of the ice is 690 kg. The density of the water is 1000 kg per meter cube. Pond X is 0.545 meter below the ice. Calculate the pressure at the point due to the ice and the water. So we need to calculate the pressure. We know there are two types of pressure present in this case. First is pressure due to ice plus pressure due to water. So pressure due to ice, we're gonna apply this formula F over A plus for the water rho GH, and we are provided with the density as well, mass, area, density and height. Everything we have been provided. So we're going to use this formula to calculate pressure. Force is not directly given, so we're going to calculate force by this formula. Force W is equal to mg, where W is equal to force. Weight is equal to force mg over A plus rho gh. Now we're gonna substitute our value to calculate the answer. Mass is given, that is 690. We're gonna use the value of G 9.8 given in the start of the instruction. Area is 5 plus rho g, density is given, that is 1000. Again 9.8 multiplied by the height is given, that is 0.45. So we're gonna multiply these and calculate these values with, and the answer would be 135.2.4 plus 4410, and the final answer after adding those values would be 5762.4 Pascal. And we're gonna use standard form and write our answer in two significant figure like that, 5.8 into 10 raised to power 3. If you can write 5.7, it would be considered right as well. Now moving to the next question number 4. You can look back to this question and take the screenshot. Okay, now we will move to the question number 4. Question number 4 is from the topic of temperature. The temperature of a fixed mass of a gas constant volume is decreased. State and explain in terms of particle how the pressure of the gas changes. We know that when the temperature of a fixed mass at the constant volume is decreased, the pressure will decrease, because when the temperature is decreased, the particles have less energy. When the particles have less energy, they have low chances of collision, because they cannot move as rapidly when they have more energy and more temperature. So their chances of collision will become less, so they will experience a less pressure, and pressure will also decrease. So overall it will particles experience smaller impulse change. So we're going to write our answer like that. The pressure will decrease due to the particles having smaller velocity cause of low temperature, leading to low chances of collision with the wall. Particles experience smaller impulse change. So this was an easy explanation. You can write in your own words as well. State the value of absolute 0 in degrees Celsius. We know that absolute 0 is equal to 0 Kelvin, but we need to write our answer in terms of Celsius over here. So we're going to write that minus 273 degrees Celsius. Absolute 0 is the temperature where volume of the object becomes 0. Next, explain what is meant by absolute 0. Refer to the particle in your answer. So we need to answer in terms of particle temperature at which the particles have the lowest possible kinetic energy. So we're going to write over here, it is the temperature at which particles have lowest kinetic energy. Moving to its C part, cylinder 1 contains cylinder 1 contains 350 centimeter cube of a gas at a pressure of 9 into 10 raised to power 4 Pascal. The gas is transferred to the cylinder 2 and the pressure increases to 1.6 into 10 raised to power 5 Pascal. The temperature remains constant. Calculate the volume of the cylinder. So this is the again the question of the pressure, and formula we're gonna use over here is P1 V1 for the ideal gases, P2 V2. We have been provided with the pressure 1, that is 9 into 10 raised to power 4 Pascal, and the volume 1 is also given, that is 350. Now the pressure 2 is 1.6 into 10 raised to power 5, but we have not provided with V2. So we're gonna rearrange like that. V2 is equal to 9 into 10 raised to the power 4 multiplied by 350 divide by 1.6 into 10 raised to the power 5. So after calculating it, our answer would be 200 centimeter cube. So we're gonna write over here 200 centimeter cube. This is the answer for question number 4, last part C. Moving to the question number 5. Question number 5 belongs to the topic of density is first part, and the other part is from the temperature specific heat constant. So question number 5, okay, shows an electric heater used to heat a room. The dimension of a room are 4.5 into 6.1 into 2.4. So we're gonna multiply them to calculate the volume, and the density of the air is 1.2 kilogram per meter cube. So after multiplying this, we're gonna get volume, and the volume would be 4.5 6.1 multiplied by 2.4. It would be 65.88 meter cube. We know that the formula for the density is mass over volume. So mass, for calculating the mass, it should be mass is equal to density into volume. We have been provided with the density is 1.2, and we have calculated the volume, that is 65.88. we need to show this value. The mass would be 79 kilogram. After calculating it, the mass is 79 kg. This is how we have shown that the mass for this would be 79. Moving to the next part, the power of the heater is 1100 watt. The specific heat capacity of air is 1000 kilogram joule per kilogram degree Celsius. Calculate the time taken to increase the temperature of the air in the room from 16 degrees Celsius to 20 degrees Celsius. We note that we have the formula for the Q, that would be mc delta T. It would be mass is 79. We have calculated just specific heat capacity is also given, that is 1000, and the change in temperature would be 20 minus 16. After solving it, we're gonna get the energy value, that would be 316 joule, 316,000 joules. But we have been provided with the power, and we need to calculate the time. The formula for the power is W by T. W we're gonna use is Q by T. After rearranging, T is equal to Q by P. Energy is, we just calculated 31600. Power is given, that is 1100 watt. After calculating these values, our answer would be 287.2 seconds. So we're gonna take to two significant figure, 290 seconds would be our final answer. Moving to its next part, suggest one reason why the time calculated in second part is the minimum time to increase the temperature of the air from 16 to 20 degrees Celsius. Heat energy is transferred to object in the room through doors, and heat energy can also be entered from the window. So we're gonna write over here our answer. So it is the minimum time required because heat energy can transfer in the room through doors and window. Heat energy is transferred to objects in a room through doors and window. Moving to its next part, Figure 5.2 shows a cross section of a double glazed window in the open. Outer glass plane, narrow air gap, inner glass pane. State the methods of thermal energy from the room to the outside which are reduced by this type of window. So it would be conduction and convection. We need to write both these methods even though it's a 1 mark question, because answer key carry both these transfer method. Moving to question number 6. Question number 6 is from the topic of wave. Two types of seismic waves are P waves and S waves. State the types of wave that P waves and S waves can be modeled as. P waves would be longitudinal waves, and S waves would be transverse waves. Moving to its B part, the velocity of P waves in the Earth's solid crust is 7.2 km per second and its frequency is 4.5 Hz. Calculate the wavelength. We know that wavelength V is equal to F lambda, and lambda is the for wavelength, lambda would be V by F. So first we're gonna calculate velocity. Velocity is given in terms of 7.2 kilometer per second. We're gonna change it by multiplying it by 1000, so it would be 7.2 meter per second, and the time and the frequency is also given, that is 4.5. so we're gonna divide these two value, 7200, sorry, we're gonna write over here 7200 divided by 4.5. our answer would be 1600 meter. That would be our wavelength value. Okay. This was an easy question. Question number 6 has done. Now moving to question number 7. Figure 7.1 shows a container of oil. Container is this. A ray of light enters on the surface area with the refractive index of oil is 1.47. So the refractive index of the oil is given, that is 1.47. Okay. Now on figure 7.1, draw the normal at the point where the ray enters to the oil. Okay, so we're gonna draw the normal line. We're gonna use the scale over here. So this is how we are gonna draw our normal to the plane where the ray is entering. So that would be 90 degree. This angle is given. Okay, for the next part the angle is 56 degrees, so value of x is 56, but this would be our incident angle, and we're gonna calculate incident angle by 90 minus 56. It would be 34 degree. Okay, calculate the value of angle of reflection. So we're gonna need to calculate the value for the angle of reflection. We have already calculated the value of incident angle, that was 34 degree. So with the help of refractive index formula we can calculate the value of refractive angle. N is equal to sine angle I over sine angle R, means value of refracting index was 1.47, sine angle I we have just calculated sine 34, angle of reflection we need to calculate sine R. So we're gonna take sine R here, and sine 34 divide by 1.47. We're gonna take the inverse. Sine inverse is equal to sine 34 over 1.47. Our answer would be the angle of refraction, that would be 22 degree. I'm gonna write 22 degree over here. So the final answer is 22 degree. Moving to the next question, state the part. Okay, state the approximate speed of the light in the air, and we know that approximate speed of light in the air is 3 into 10 raised to power 8 meter per second, ms minus 1. Moving to its D part, calculate the speed of light in the oil. Give your answer correct to three significant figure. So we note that the formula for the refractive index is that the speed of light in vacuum divided by speed of light in oil. So 1.47, this value, speed of light in the vacuum. Oh, sorry. Now you can see this formula, and we're gonna apply. Speed of light is 3 into 10 to the power 8. We need to calculate the speed of oil. We're gonna say VO. VO is equal to 3 into 10 to the power 8 divided by 1.47, and the answer would be, we need to write our answer in three significant figures. So we're gonna write 2.04 into 10 raised to the power 8 meter per second. So we're gonna write over here 2.04 into 10 raised to the power 8 meter per second, because answer was required in three significant figures. So we have write our answer in three significant figure. Moving to question number 8. State what is meant by magnetic field. Magnetic field is the region around the magnet where its influence can be felt. So we're gonna write this answer, the region around the magnet where force acts on another magnet, or you can write where its influence can be felt by other magnet. Moving to the next, define the direction of a magnetic field. The direction of the force of the magnetic field will be north. The magnet will always point towards the north. So we're gonna write our answer, the direction of the field will be towards north pole. Moving to the next part, figure 8.1 shows a negatively charged metal sphere. Draw 4 lines to show the electric field and its direction. So when I draw the 4 lines, it will be like that, because the sphere is carrying negative charge. That why we're gonna draw these arrows like that. Or if here it was a positive, then we need to move away the arrow from the sphere. Okay, moving to the next part C, figure 8.2. okay, you can see now figure 8.2 shows a circuit. The 3 cells are in the identical, have 0 resistance. Okay, the resistor R1, R2 and R3 are identical. It means they have the same value of resistance. The reading on the voltmeter is 6 volt. When the diode is conducting, it has 0 resistance and 0 potential difference across it. Determine the value or determine the EMF on the one cell. So we know that we have been provided with the voltage, that is 6 volt, and we have Determine the EMF on the one cell. So we EMF on the one cell, it is moving from the 2, so we're gonna divide it. It is moving to the 3 identical resistors, so we're gonna divide by 3. Our answer would be 2 volts. So EMF would be 2 volts on 3 identical cells. Okay, determine the ratio of potential difference in the charge across R2 to potential difference across R3. So we know that R1, the current potential difference would be it's coming from here would be 6 volt, then it going to divide into 3 because they both are equal resistance. Now moving to it would be combined, and again 6 volt would move from here, but we need to calculate the resistance across across R2 and R3. So resistance R1 would be 3, R2 would be 3, and R3 would be 6. So we're gonna we have there is voltages, so we're gonna take the ratio between R2 and R3. It would be like that, 3:6. It gonna cancel it, the answer would be 1:2. Moving to next part, all cells are reversed. State and explain the change in the current in R1. Current in R1 would be 0 because of the diode is in the wrong direction. When we reverse the direction, now it will move like that, and the R1 there will be no current because this diode would not allow in this position to move the current charges. So we're gonna write that current in R1 is 0 because of diode in wrong position. Next, determine the new value of the ratio of the P potential difference across R2 and R3. The new value, because now current would not produce a move here potential difference, so all the voltages would be flown from here. It would be 6 volt, and the ratio between these would be 6/6. So 6:6, and the answer would be 1:1. This was our question number 8. Moving to the second last question, question number 9. Question number 9 is from the topic of radioactivity. Table 9.1 shows some properties and values of alpha particles, beta particles, and gamma radiation. Complete table 9.1. Alpha particles is 2, 0, and we know that number of protons in the beta particles are 0. Number of neutrons is 0, and we know that number of neutrons due to helium particle is like that, 4, 2, and the helium particle would show that 4 minus 2, number of neutrons 0, and for gamma particle as well 0. And the charge on the beta particles would be -1 due to electron, and gamma particle would not carry any charge. And what gonna stop the gamma radiation? Thicker lead wall would stop the gamma radiations. Okay, moving to next part. State how beta decay changes the nucleus of an atom. The nucleus of an atom will have one less neutron and one more proton. So this is how I'm gonna write how beta the nucleus of an atom will have one less neutron and one more proton. You're gonna write over here one more proton, or you can simply write one less neutron and one more proton because space was given very little. Now moving to its next part, which is a very technical part of this paper. It's a challenging question. A radiation detector used in the laboratory detects a background count rate of 30 counts per minute. This is an important information. A radioactive source is placed in front of the radiation detector. The initial reading on the detector is 550 counts per minute. The half-life of the source is 25 minutes. Calculate the expected reading on the reader after 75 meter on the detector. We know that 550 counts per minute is equal to 30 counts per minute, or you can say that 30 counts per minute but in the background, so we're going to subtract 520 from 550 from 30, so our real count would be 520 count per minute. Okay, we know that its half-life is given, that is of 25 minutes, and we're gonna use this as detector is after 75 minutes, so 75 over 25 would be 3. It means 3 half-lives we're gonna use. So we're gonna tell like that 520, one half-life will reduce into 260, second half-life will reduce it into 130, and the third half-life will reduce into 65 counts per minute. And if we add the background effect 65 plus 13, because first we have already subtracted it, so now we're gonna add back it, the answer will be 95 counts per minute. So this is our final answer, 95 counts per minute. I'm going to repeat. First we subtracted 550 to its background radiation, then the count minutes will be given 520. Now, after that we calculated the half-life, that is from 75 dividing by 25, that would be 3 half-life. Then we converted into 3 half-life. 520 first half-life would give us 260, then 260 second half-life would give 130, then the third half-life would give 265. Then adding 65 into previous answer, previous background radiation which we have subtracted 65 plus 30, answer would be 95 counts per minute. Stage 2, safety precaution. Then moving, using or storing radioactive. Store the source in the lead box because it will protect. Store the source in the lead box. It will not allow to radiate anything from to outside the box. Limit or minimize as much the time of exposure you can. Limit the time of exposure. Moving to last question, question number 10 of this paper. State the equation. Okay, state the equation that define the average orbital speed of a planet. State the meaning of any symbol you use. So the symbol would be V is equal to C by T. C by T means distance by time, and distance is by the circumference. 2 by 2 pi r over T, where r is equal to radius of orbit and T is equal to orbital time period. So we're gonna write that orbital period. Moving to its B part, suggest why countries that are significant distances from the equator experience the significant temperature variation throughout the year. Because rays from the sun strikes, rays from the sun strikes the country at different angles throughout the year. due to the tilt of earth, so temperature varies due to this reason. Okay, fill in the gaps in the paragraph. This is a very important part. This question also come in the O levels paper. Fill in the gaps in the paragraph about a star much massive in the sun. The stage that follows the stable state in the life cycle of the star is dash state. It is the red supergiant stage. Now it then explodes as a supernova to form a dash, to form a nebula. That just leave behind. Okay, wait. So we're gonna write that this leaves behind a nebula, no, neutron star, or you can say black hole. Moving to the last part, a galaxy is moving away from the Earth with a speed of 3300 km per second. The value of the Hubble constant is 2.2 into 10 raised to power minus 18 per second. Calculate the distance from the galaxy of the Earth. Give your answer in the light years. We know that velocity is v is equal to, given that is 3300 km per second, and Hubble constant is given, that is 2.2 into 10 raised to power minus 18 per second. Okay, 1 light year, we know that it is equal to 9.5 into 10 raised to power 15 meter. We're going to apply this formula 1 over h naught over d by v. We need to calculate d, so we're going to rearrange v over h naught. We have been provided with the v, that is 3300 divided by Hubble constant, that is 2.2 into 10 raised to power minus 18. Our answer would be now 1.5 into 10 raised to power 25 meter. We know that 1 year would be equal to 1.5, we just calculated, into 10 raised to power 25 divided by 1 light year, that is 9.5 into 10 raised to power 15. After solving it, we're gonna get the answer for 1.57 into 10 raised to power 9 light year. So we're gonna use this answer as two significant figure, 1.6 into 10 raised to power 9 light years. Thank you so much for watching this video. Hopefully you get the understanding of this paper. If you do have any inquiries related to this paper, you can ask in the comment. I will answer it, and do refer it to your friends, and don't forget to subscribe this channel and like the video. Thank you so much. Allah Hafiz.